So welcome back to today's class. So from now onwards, we are going to start with a very interesting and a very simple topic, that is trigonometry. So just follow whatever we are going to do in the coming few classes, and by the end of this topic you would be able to solve any question from any book, because it is actually a very simple topic. But just keep this thing in mind that you have to understand this topic as I would be telling you. Just follow whatever I am telling you, and by the end of this topic you would be able to solve any question very easily. Topic otherwise is very straightforward, but you need to follow the basic logic which we would be discussing so many times in between the questions. So first we'll understand that how this topic is important to us. What's the reason that we are actually studying trigonometry? What's the use of trigonometry further? So let's discuss that. So we are going to discuss the uses of trigonometry. So first we'll understand actually that what trigonometry is going to do, what we are going to do in this topic. So trigonometry, this is the branch of mathematics. So trigonometry is actually that branch of mathematics which deals with the relationship between the angles and sides of a triangle. So we are actually in a way going to connect somehow the angles and the sides of a triangle. Like for example, any triangle is given to us. So we are going to create a method through which the angles of the triangle and the sides of the triangle are going to be connected. So this understanding we are going to develop in this topic now onwards, and it is very straightforward. But whatsoever be the place, wherever triangles are used, that is the place where trigonometry comes into play. For example, in architecture and construction, this is a huge topic in this area, because whatsoever bridges which we are seeing all across the place, any bridge, any building which we are seeing, they all actually involve trigonometry at so many places. Whatever construction which we can imagine, it involves actually trigonometry at so many places that we can't even imagine at this moment. It is so important for this particular field. Similarly, in navigation and maps, whenever we actually seeing some angle or something, so that also involves complete trigonometric sense. In GPS, like we all just use Google Maps or Apple Maps, and we actually unknowingly are using trigonometry, but we don't know that. So now we are going to understand the core behind it. What's the logic of actually all the navigation and GPS which we are using on a daily basis for so many times. Similarly, for surveying and landscaping, it is sort of a related field only. In physics also, it's of great use. In engineering and robotics, whatsoever actually involves trigonometry, whatsoever actually involves triangles, over there trigonometry comes into play for sure. And these are only some examples. This is not a complete use case. So besides this, there are so many other places where trigonometry is used, but those fields at this moment are totally unknown to us. So let's just explore what this topic holds for us, and then we would be able to, let's build the base strong, and after that, as and when your growth tree, actually your tree just rises, you further rise in life, and then you would be able to see by yourself that you are using trigonometry at so many different places. So let's just get into the topic now and understand the basic logic. So now this is the basic topic which we are going to discuss in today's class. We are going to completely discuss the understanding related to this triangle. So just focus upon this triangle, this right angle triangle. So if this right angle triangle has base as x, this vertical side as y, and this side as r. This is x, this is y, and this is r. And I'm just introducing a new way to represent an angle, that is this symbol theta. This is this symbol theta. So now onwards, just keep this symbol in your mind, because I would be using this name for so many times. So this angle is theta, and this angle over here is 90 degrees. So we are taking into consideration a right angle triangle in which one angle obviously is 90 degrees, which is this vertical angle, and this is the height y, and this angle over here is theta. This symbol represents theta. It's a Greek symbol which represents angle in general. So this is angle theta, and we can directly judge that if this is 90, this is theta, then since this complete triangle has angle as 120 degrees in all, so the angle which remains over here, it would be 90 minus theta. I'm not marking this angle as 90 minus theta, but we know this thing. So now coming back to the actual topic. So in this right angle triangle, we are going to learn 3 new ratios right now. We are going to learn just 3 new easy ratios. First ratio is this perpendicular, this is the height, this is the perpendicular, and this is the hypotenuse. So this first ratio is perpendicular upon hypotenuse, and its name is sine. It is actually sine, sine, but we normally use this symbol as only sin, and we are actually talking about the angle of this. If I'm talking with respect to this angle theta, so we label sine theta as this perpendicular upon hypotenuse. So sine theta is actually perpendicular upon hypotenuse, which in this case is y upon r. So just remember and just speak it with me that sine theta is perpendicular upon hypotenuse. So look, this is the base, base actually the angle which is associated with the base. So this is the angle theta, this is 90. So base would be that angle, which is base would be directly that place where this angle theta is actually connecting with the side other than the hypotenuse. So this is the base, this angle is theta, this is the height. So sine theta is perpendicular upon hypotenuse. Just remember this thing now onwards, that sine theta, sine of this angle, is a ratio which is perpendicular upon hypotenuse. How we are going to use it, why we are doing it, we'll just come to know in so many questions now onwards. But the first requirement is this, that we are able to say to ourselves that sine theta, we know that it is perpendicular upon hypotenuse. Similarly, the next name is, I'm just rubbing this over here. Next name is cosine. cosine, it is cosine. So we represent it as cos theta. So I am again talking with respect to only this angle theta, which is the base over here. So cos theta is actually base upon hypotenuse. Sin theta was perpendicular upon hypotenuse. Cos theta is base upon hypotenuse. Base upon hypotenuse. So in this case, it would be x upon r. So just say to yourself that we know that, just remember this thing, that sin theta is perpendicular upon hypotenuse and cos theta is base upon hypotenuse. X upon r in this case. So these are two simple terms. We have just learned two simple trigonometric ratios. One is sin theta and the other is cos theta. Sin theta is perpendicular upon hypotenuse and cos theta is base upon hypotenuse. Now comes the simple last name as of this moment, that is tan. Its full name is tangent, and tan theta is equal to perpendicular upon base. This is perpendicular upon base, which in this case is y upon x. So we have right now just learnt three trigonometric, easy simple trigonometric ratios. One is sin theta, which is perpendicular upon hypotenuse, y upon r. Next is cos theta, which is base upon hypotenuse, x upon r. Just remember this thing. And next is tan theta, which is perpendicular upon base. Tan theta is perpendicular upon base. So these are the three ratios which we have to learn as the most basic sense, and in most of the questions we are going to just apply this logic.